Algebra 2 Honors, Lesson 6.5, the Quadratic Formula and the Discriminant. Wouldn't it be nice if we didn't have to complete the square like we've been doing? Make it like one step. Well, you can ignore the following if you want, but I'm going to actually show you how the quadratic formula is derived. I'm so excited. Move the c over. Ax squared plus bx equals negative c. Divide it out. The a, that is. We have x squared plus b over a x equals negative ca. Remember, b over a over 2, which is just b over 2a. b over 2a squared equals b squared plus 4a squared. Add it to both sides. What's in the box? X plus b over 2a. Gotta do a little fancy algebra on the left here. Gotta multiply this by 4a over 4a to get a common denominator. So on top we get negative 4ac plus b squared all over 4a squared. Square root of both sides. I'm going to rewrite the inside over here. Well, let me do the left side first. X plus b over 2a equals, the bottom I can take the square root. The bottom is not too bad. It's 2a. The top I'm going to rewrite inside the radical for the b squared first. Just kind of rolls off the tongue nicer. And don't forget your plus or minus. Now we're going to subtract b over 2a from both sides. It's already set up with a common denominator. So that's quadratic formula. Now you can be very, very, very dumb and just plug in values. You need to memorize that. I will not give it to you. It's not that hard. So I call it plug and chug. That's what engineers call it. Here's how I do it. First things first, set it equal to 0. If you're one of those people, you need to do this, you go right ahead. But the first thing I do is the inside. It's called the discriminant. The inside of the radical. And I do that because it tells me right away, do I have 2 real roots, 1 real root, 2 complex roots? So I do that usually up here, but it's up to you. B squared is 144 minus 4 times 1 times negative 28. See what we get here. Watch your negatives, one of the biggest problems people have. I get square root of 256, which is plus or minus 16. So x equals negative b, 12, plus or minus 16 over 2 times 1. X equals 12 plus 16, which is 28 over 2, 14. X equals 12 minus 16, which is negative 4 over 2, negative 2. Done. I'm going to write this over here because it's getting in the way of this. Let's try again. Once again, if you want to do it, by all means. A equals 1, B equals 22, C equals 121. I throw it up here. 22 squared, 484 minus 4 times 1 times 121 equals 0. Interesting. X equals negative 22 plus or minus 0 over 2 times 1. X equals negative 11. So we're going to ask you to say how many roots, what kind. This is 2 real roots. And I know that because the discriminant is positive and it's not 0. Over here we get 1 real root. As we know from previous graphing, this will touch the x-axis once, this will touch the x-axis twice on the left, so on and so on and so on. So one more where the a value is not 1, but it doesn't really matter. A equals 2, b equals 4, c equals negative 5. 16 minus 4 times 2 times negative 5. I get square root of 56, which I believe is 2 root 14. Yep. So x equals negative 4 plus or minus 2 root 14 all over 2 times 2. X equals, you know what, I'm not going to break it into 2. I got a radical up there. I can divide out 2 here, here, and here. X equals negative 2 plus or minus root 14 over 2. Could simplify that, change it a little bit. I don't know if I would call it simplifying, but might as well just leave it as is. Now, this is what we're talking about. Oh, I nearly forgot. 2 real roots. Oh, but they got radicals. Doesn't matter, it's still real. So how do we check if we have a real solution? Check the discriminant. And again, the discriminant is b squared minus 4ac. Positive, real. And let's write that out properly. 2 real. 0, 1 real. Negative, too complex. No real roots. We call this the discriminant, as I've already discussed. So sometimes they can ask questions like this. I really won't. How many roots for each of the following? In which case we just go straight to the discriminant. 64 minus 4 times negative 5 times negative 1. 64 minus 20. 34. 2 real roots. $144 minus 4 times 9 times 4. Look at that. 0. 1 real root. And 16 squared is 256. minus 4 times 2 times 33. We get negative 8. So we have 2 complex roots, no real roots. Now, all of this is interesting. It's trying to tie together the concepts of graphing and factoring and completing the square and the quadratic formula. But the reality is the way I do the problems, where the first thing I calculate is b squared minus 4ac, kind of leads you to that point where you'll say, oh, that's positive, that's 0, that's negative. You don't really have to think too hard about it. That's it. Make sure you memorize it. Good luck.